Welcome to an SAT mathematics video. In this video we are actually looking at ratio, proportion and kind of that sort of thing. So we're not looking at how to convert a fraction to a decimal and decimal to a percentage and so on, because I believe that's something that most people already do know. All of you will know about. So but just in case you want to recap, or you you want to recap, right? You can just pause the video right now, look at it, and then come back, right? So the approach we're using for this video is we're actually going to look at questions and then cover any underlying concepts associated with them. This is because I think fractions and percent and ratio and proportion, these are very elementary concepts that we start learning from 3rd grade and so on. So most of us are very familiar with it. So I think the video would be more useful for you guys if we just had a good number of questions. So that's what we're going to have for this video. Pause the video at every question, attempt it yourself, and then of course the solution will be presented, right? So the first question we're going to look at, for how many integers a is between 50 and 60 is this is 15. Is 15 by a and 16 by a in its simplest form, right? So something you need to realize is a fraction is in its simplest form when the numerator and denominator have no common factors. So if 15 and a have a common factor, it is not in its simplest form, right? If 16 and a have common factors, it is not in its simplest form. So the first thing you want to do is find the prime factors of both 15 and 16. 15's prime factors are 3 and 5, 16's prime factors, it's only 2, right? Therefore, if any number between 50 and 60 is divisible by either 2, 3 or 5, it is not an appropriate value for a, because at that point 15 by a or 16 by a, at least one of them will not be in its simplest form, right? So at this point, what we're supposed to do is eliminate any of these numbers that are divisible by 2, 3 or 5. We realize 53 and 59 are the only such numbers, and therefore the answer is 2. Question number 2. When x is equal to 3 by 7, which of the following is greater than x? A pretty standard solution will be get your calculator out and substitute 3 by 7 wherever there is x on your calculator and see whether the resulting answer is greater than 3 by 7. That is a perfectly fine approach. But assuming this is a non-calculated question, you can still do it. 1 by x is nothing but the reciprocal of x. That is basically the fraction flipped, which is 7 by 3. 7 by 3 is greater than 1. 3 by 7 is smaller than 1. Therefore, 7 by 3 is greater than x, which is... so therefore, the first statement is correct. The cube of 3 by 7 would be a positive number that you're adding to x. If you add something to x, the resultant sum will be greater than x, so that also has to be true. For the third question, something you need to realize is that 3 by 7 is greater than 2 and 3 by 7 is smaller than 2, right? Which means the denominator over here will be negative while the numerator over here will be positive, right? When you're dividing when a positive number is being divided by a negative number, the resultant number would also be negative, which would be smaller than 0 and therefore would be smaller than x, right? So even if it was a non-calculated question, you can pretty much logic it out and get it, right? Third, you'll often get questions like this: find the possible value of x if it lies between two fractions. So there are many possible answers to this. They will not penalize you. There is not one specific answer they're looking for, but here's the thing. Just to play it safe and do it really quickly and not really spend time thinking about it, find the average of the two fractions they have listed. So because the average will lie exactly halfway between the two fractions, and when you get that, it comes out to be about 9 by 20, and that is a good value for x. Put that in and move on. 4, so you might often get questions like 11 is 1 by 8% of what number, or 3 is 1 by 10% of what number, or 7 is 3% of what number. So the first step is to write that corresponding percent and then write how much what that number is. So here 1 by 8% is 11. The next step is always to find out what 1% would be. So in this case, we multiply both sides by 8. Therefore, we get 1% would be 88. If we heard that 8% was 11, we would divide both sides by 8. And we would get 1% as 11 divided 11 by 8. once we have 1%, we multiply both sides by 100, so that we'll get 100, and therefore we get 100% is 8800. 100% is basically that number, and therefore the number is 8800. This method is called the unitary method in many places, and it's quite a nifty thing to know. Alternatively, something you can do is convert this to a decimal. So 1 by 8% is 0.00125. 11 divided by 0.00125 would give you 8800 as well. So if, let me just confirm that really quick, because I haven't written it down. Right, so it does give you 8800, and that's another way to do it. So you don't need to use the unitary method with this one, but it's a good method to know. Another type of question that you do get is the car. So something's value might depreciate or appreciate by the end of something, and they'll ask you to find the original value, right? So in this question, the car's value is depreciated by 13%, and it is now worth 8,700. So they're asking you for the original value. What's important to realize is that the car is currently worth 87% of its original value because it is depreciated by 13%, and 87% of the car's original value is 8,700. Therefore, once again, we'll try to find 1%, that is 100, and therefore 100% or the car's original value was $10,000, right? If it was appreciate, if this had said that it had appreciated by the end of the year and was now 8,700, we would instead say that 113% is 8,700. Therefore, 1% is 8,700 divided by 113, and therefore the original value was 8,700 by 113 multiplied by 100, right? We use this method when we have the final value and we're trying to calculate the initial value, right? But there are many questions where they might give you the initial value and then they want you to find the final value. In that case, you do use our standard method. So if I say a bond is worth $100 and it appreciated by 13% over the year, I'll just multiply 100 by 1.13 or multiplied by 113 into 100, and we'll get the final value. So that is the standard thing. So I'm not going to write that down or go into detail about that. But calculating the initial value can sometimes be tricky, and some people do get confused about that. So I've put it out here. You'll often also get questions like a special shade of green involves 4 parts of blue, 3 parts of yellow, and 1 part of white. So what percent of the mixture is yellow paint? So your first step is to write down the ratio. So it's 4:3:1, and calculate the number of total parts. So that is 4 plus 3 plus 1. That's 8 parts. Therefore, we know that 3 out of the 8 parts are yellow. Therefore, the fraction that is yellow is 3 by 8. Once we have that, we just need to convert that to a percentage, and that is 37.5%. So pretty simple question once again. You might also get questions like this. So with angles, it's a pretty common question. So then you might hear something like a triangle has angles in the ratio 2:2:5. Which of the following must be true? So the first thing you need to realize is that if all the angles are equal, the triangle is an equilateral triangle, and the ratio of the angles is 1:1:1 because all the angles are 60. If only 2 angles are equal, the triangle is isosceles, and the ratio would be x:(y), where x and y are different numbers. This is because 2 angles are exactly the same. Therefore, the ratio or the fraction of 180 they represent is equal. And if all 3 angles are different, you would get a ratio, and the triangle is scalene, and you would get a ratio in the form x:(y:z), where x, y, and z are different numbers. Here we see that 2 of the numbers are same. Therefore, it means 2 of the angles are equal, and the triangle is definitely isosceles. We realize that these 3 things are mutually exclusive. So if a triangle is isosceles, it cannot be equilateral and scalene anymore. Therefore, we can say that since we do know that the triangle is isosceles, it cannot be scalene. Therefore, 2 is true and 1 is false. For the third statement, we'll need to find out what the angles are individually. We know a triangle is 180 degrees. We calculate the total number of parts, 2 plus 2 plus 5, that's 9. 2 of the angles are 2/9 of 180 degrees, while the final angle is 5/9 of 180 degrees. We calculate that. That means the angles in this triangle are 40, 40, and 100 degrees. There is no 90 degrees over here. Therefore, the triangle does not have a right angle, and therefore that is false. We could have done this directly, and we would also identify that 2 angles are equal and the triangle is isosceles. So that's up to you, really. You could have just found the angle straight away and not really done it into separately. But that's how you would approach a question like this. Another question that might come is to what is the ratio of the diagonal of a square to its side length, or what is the ratio of the circumference of a circle to its diameter, and things like that. So it's pretty simple. Like most of us, some of us may know that there is a formula for the diagonal of a square, that is, it is a root 2 if a is the side length. The value of the length of the diagonal is always going to be a root 2. Therefore, the ratio of the diagonal to the side length is a root 2 to a, which is root 2 to 1. So now sometimes the SAT expresses ratios as fractions, and they ignored the 1 in the denominator, because you can write this as root 2 divided by 1, and we ignored the 1 in the denominator. So therefore, the correct option may just be written as root 2. That is the same as this, so do not worry about that. Now, in case you didn't know the formula for this particular question, something you could have thought of is that this is the diagonal, this is the side length of a square. So you can think of the diagonal as the hypotenuse for this right angle isosceles triangle, where this side length is a and this side length is a. Therefore, using Pythagoras theorem, the diagonal would become the root of a square plus a square, which is the root of 2a square, which can be written as a root 2. Once again, you would arrive at the expression at the ratio a root 2 to a, which is root 2 to 1, and therefore we would once again arrive at the correct option, even if we didn't know the formula. And that's the thing, the SAT does not expect you to know many formulae except a few basic ones like area of a circle, volume of a prism, and things like that. So many times for things that you think are obscure, like you might have not known that the formula for the diagonal, there is always another way to do it. So it's perfectly fine if you didn't know the fact that the diagonal is always a root 2. And the final question that I do want to cover in this topic that does come about is questions like this. So they might say it takes 12 days for 20 builders to build a house, or 3 days for 5 painters to paint a wall, and things like that. So in this question, we are saying it takes 12 days for 20 builders to build a house. So how many days would it take to build the same house if 48 builders were employed instead? Now, these questions always have a very standard approach. It never changes. You multiply the first two quantities, 12 into 20. That comes out to 240. Think of this as 240 arbitrary units of work. Now divide that by the number of builders, and therefore you get 5 days, right? It's very simple. Multiply the quantities in the first scenario and divide it by the given quantity in the second scenario, and you will always get what you need to calculate. It's very easy. Like, no matter what the context is, this is how you're going to approach a question that looks like this, right? And with that, in the next video, we're going to look at, again, something that's pretty easy: mean, median, mode, range, IQR, so the interquartile range, the lower quartile, the upper quartile, and box plot diagrams. And with that, thank you guys. Have a great day. Thank you.